friends, welcome to the science class. In last session under the chapter of magnetic effect of electric current, we discussed about how an electric current carrying conductor acts as a magnet, isn't it? We know about how an electric current carrying conductor acts as a magnet, and also we studied or we see an activity in last session. That activity shows that when a rod or when an electromagnetic conductor placed inside or placed perpendicular to the another one magnetic field, the magnetic field applied somewhat forces to that rod, isn't it? So we studied in last session. That activity shows that by changing the direction of the magnetic field or by changing the direction of the current, we get the motion of the rod inside a horseshoe magnet. That shows the magnetic field which acts perpendicular to the another one magnetic field or another one electromagnet that pushes that rod, isn't it? That shows that the magnetic field applies some force on another one magnetic field. Using that phenomenon, the Fleming says one rule, that is Fleming's left hand rule, we studied in last session, isn't it? What it shows, what it says, the Fleming's left hand rule. So when you have to arrange your first three fingers of your left hand in such a way that all three fingers they are perpendicular to each other. The thumb finger indicates the direction. See, the thumb finger indicates the direction of the motion here. The forefinger indicates the direction of the magnetic field, and the other one, the middle finger, indicates the direction of the current here, isn't it? So when the current flows through the circuit in the direction of this way, if the magnetic field it is perpendicular to the direction of the current, then that magnetic field will apply some force on that rod and that will be moved. Using that property, the electric motor will be made. So using the left hand rule, the Fleming's left hand rule, it is also called it as a motor rule. The Fleming's left hand rule, it is also called it as motor rule. Yes, the Fleming's left hand rule, that is also called it as a motor rule. So now in this class we are going to study how the motor can be made, how it is constructed and how it is working. So first I am considering here electric motor, the construction. See here, in your examination 4 to 5 marks question should be asked on this. The question will becomes like this: write down construction and working of electric motor, or another one question will be there here, the write down the construction and working of electric generator. You have to draw the diagram and you have to write down the construction and working of electric motor, how it is works. See, first construction. According to the figure you have to write down here. So electric motor consists of a rectangular coil. You have to write down here. Electric motor consists of a rectangular coil, either maybe a copper or iron, rectangular copper coil. ABCD. Electric motor consists of a rectangular copper coil ABCD placed in between two magnets, in a such a way that the sides AB and CD are perpendicular to the magnetic field, the direction of the magnetic field, in a such a way that the sides AB and CD are perpendicular to the magnetic to the direction of the magnetic field, to the direction of the magnetic field. See here, an electric motor consists of a rectangular coil placed in between two magnets. This N represents one magnet and S represents one magnet here. And this ABCD is a coil. ABCD is a copper coil, that is a rectangular coil that is placed in between two magnets in a such a way that the sides AB and CD, the AB will be perpendicular to the perpendicular to the direction of the magnetic field N, the magnetic field produced by the magnet N, and the side CD will be the perpendicular to the direction of the magnetic field produced by the magnet S. You have to remember here, this is the first point. And second point here, the two ends of the copper coil, the two ends of the rectangular coil, the two ends of the rectangular coil are attached to the two split rings P and Q. Two split rings P and Q, and these split rings, the inner sides of the split rings, the ends of a two rectangular coil are attached to the two split rings P and Q. The inner sides of the split rings are insulated and attached to the another one coil, attached to the axle. See here, the two ends of the rectangular coil are attached to the two split rings. These are the half rings here, two split rings, and the inner sides of these split rings, the split rings are P and Q here. The inner sides of the split rings are insulated and attached to the axle. And next, see here, the two split rings has the stationary brushes called X and Y. See here, these are stationary brushes. Is it clear? The two split rings are attached to the two stationary brushes X and Y. See here, the two split rings are attached to the two stationary brushes X and Y. These are stationary brushes here, these are not moving, but these split rings are moving here. So these split rings are moving and they can exchange their brushes. The Q will be exchanged with the X when they complete one rotation. You have to remember here. So the two split rings are attached to the two brushes X and Y. Is it clear? And the brushes X and Y and the brushes X and Y are connected to the two ends of the battery, and these X and Y, two ends of the split rings, the brushes X and Y are connected to the two ends of the battery, isn't it? So this is all about construction, how an electric motor will be constructed. So once again I am repeating here, in the electric motor consists of a rectangular coil placed in between the two magnets in a such a way that the sides of the coil will be perpendicular to the direction of the magnetic field produced by the two magnets, and two ends of the coil will be attached to the two split rings P and Q, and the two split rings inside the wall of the two split rings insulated and attached to the another one XL, and two split rings are attached to the two stationary brushes X and Y, and ends of the brushes X and Y will be connected to the two ends of the battery here. So this is all about the construction and how it is working. So you have to remember here, the electric motor, it is nothing but the small DC motor which you are going to see in electric toys like electric cars, remote cars. The small motor is present. We have already seen that motor, it is nothing but the DC motor. This is the construction of the DC motor, and how it is working, that will be studied now. The working, how it works. See here, when the two ends, the ends coming from the two brushes X and Y attached to the cell, isn't it? So the electric current flows in this direction. The electric current flows in this direction when the electric current enters into the side AB. When the electric current enters into the side AB, this is a copper coil containing number of coils here. When the electric current enters to this side, what happens? This coil, when the electric current enters here, this will be converted into a magnet, isn't it? As we studied already, when electric current passes through a conductor, the conductor acts as a magnet. So when that electric current pass through this side AB, this side will be act as an electromagnet, and that due to the magnetic field. So here electric current is in this direction and the magnet is in this direction. See here, the magnetic field, it is in this direction, and the electric current is in this direction. And what happens here, according to the Fleming's left hand rule, the magnetic field, when the magnetic field it is perpendicular to the direction of the electric current, this side of the coil will be pushed down due to the magnetic field. This side of the coil will be pushed down, that is AB, the side AB will be pushed down. What happens here, then this coil will be comes here, this pushed down, and the CD will be comes here now, isn't it? So this coil rotates like this. When the electric current flows through the circuit, when the electric current enters to the side AB, that side AB become an electromagnet, and when the current flows in this direction, that is perpendicular to the magnetic field, direction of the magnetic field, that coil will be pulled downward. And a CD comes here. See here, this coil will be turns to like this. What happens when the current flows in the first step? The current flows through the first split ring, that is P. When the side AB will be pulled down, the CD will comes, this split ring will attach to the x now, because x and y are here, they are stationary, they are not moving. Due to the electromagnetic action, due to the motion of this coil, the CD will comes here, and the split ring will comes here and attach to the brush X. So in the first case, the current will comes here. When the current comes into when flows into the side AB, that will be pulled down, the electric coil will be pulled down, and the circuit completes, and the electric current comes in this direction and circuit completes. And in the second case, when CD comes here, this split ring comes here, and the split ring Q comes in the position of the P, and the split ring P comes in the position of the Q. The brush X will be attached to the split ring Q. So the brush X will be attached to the split ring Q, and the brush Y will be attached to the split ring P. And again the current flows through the brush X and through the split ring Q, and now the current enters into this side, because the CD it will be pulls down, and AB will be comes inside, and CD will becomes now. When the CD will becomes that side will becomes here, again current will be flows. When the current will be flows, again due to the electromagnetic action, that CD will also be pulled down. The continuous exchange of the current, and the continuous exchange of the split ring, this coil will be rotates continuously, and that will shows us the rotation of the coil here. The motor will be runs on the basis of this. What happens here? The change in the direction of the current. In the first way, with the help of the split ring P and the brush X, the current will be flows the side AB. When the current flows through the side AB, due to the electromagnetic property or the magnetic field directions, the side AB will be pulled down, and CD comes in the place of the AB. The split rings are exchanged here. At the place of the P, Q will comes, and Q will be attached to the brush X. Again the current will be flows through the direction. In the first case, the current will be flows in the direction of A, B, C, D, isn't it? In the first case, the current will be flows through A, B, C, D. When the half turn will be completed, CD comes at this place, the current will be flows in the direction of C, D, A, B, A. So with the help of the split rings, the direction of the current will be changes, and with the help of the change in the direction of the current, the coil will be moves up and down. The continuous movement of this coil will be gets a full rotation of the coil, and that will be done with the help of the magnetic field and the direction of the electric current here. This is all about the working of an electric motor, how an electric motor works. Is it clear? So why it is moves downwards? Why? Because so some of the force will be applied by the magnetic field direction. When the electric current flows perpendicular to the magnetic field direction of the magnetic field, some of the force will be applied on the electric field. So that's why it will be the moves downwards. The continuous movement of the coil that will get the rotation of this axle. So the coil which is comes here, the copper coil, number of turns comes here, that is call it as a armature. Now I will tell about our DC motor, what our DC motor has. So when you are going to see the parts of our simple DC motor or our professional DC motors, the DC motors doesn't contain any magnets here. If you are going to open that motor, if you are going to see the motor, there is no magnets are present. Then question arises in your mind, our sir told anything wrong. So it is, I am not telling anything wrong here. In the place of the magnets, they are going to use electric magnet. You have to remember, the electric magnet works only when the current will be passed through that material, when only that will be converted into a magnet here. So in the place of the magnets, in the professional electric motors, they are going to use, in the place of the magnets, they are going to use electric magnet, and in the place of the copper coil, they are going to use iron coil. You have to remember here, they are going to use iron coil, and the iron coil with a number of turns with the axle, that is called it as a armature in the electric DC motor. The one rod is present in the DC motor with the number of turns, number of copper coil turns will be turns wounded on a iron material, the smooth iron material, that will be called as an armature here. So if you are going to see the parts of the DC motor, you are going to only see the wounded copper wire on the smooth iron rod or iron material, but you are not going to see any rectangular coil in the DC motor. Why? Because they are replaced that rectangular coil by the smooth iron material with wounded copper coil. Is it copper wire? So that wounded copper wire with the smooth iron material with this split rings are called it as armature. Is it clear? So that armature is a main part in the electric motor. This is all about how an electric motor will works and what is the construction of the electric motor. In your examination, that should be asked for 4 to 5 marks question. So what are the uses of the electric motor? This electric motor will be used everywhere. Electric motor used in the vehicles, used in the fans, used in the mills, sawmills or atta mills. Everywhere this electric motor will be utilized, and also this electric motor will be used in bore wells, isn't it? And water motors, the motor which pumps the water, in that machine also we are going to see this electric motor. So this is all about the construction and working of the electric motor. So in the electric motor, what we see here, we are going to change the direction of the electric current and we get the rotation of the axle, isn't it? Using the electric current, we can change the electric current into a motor, that is the mechanical work. So that is with the help of the electromagnetic field, direction of the magnetic field, we will change the magnetic field, or we will rotate the copper coil here. But when the magnetic field will be the constant, if the change in the direction of that is coil will be moved, what happens? If we are going to place the magnetic field constant, if we are going to move that electric coil, what happens? So somewhat force will be get here. What happens here? When we are going to place a magnet constantly, if we are going to rotate this axle continuously, what happens here? If we are going to rotate this copper coil or a coil continuously by the mechanical work, what happens? Is it somewhat changes happens here? Why? Because the magnetic field will be, the force of the magnetic field will be applied on the coil here, isn't it? So we get somewhat changes. That changes will be first absorbed by the Michael Faraday. He makes, so now consider one activity here. Take a plastic that is cylinder like particle, a cylinder like pen like particle, and you have to own a number of copper, the number of copper rounds with the number of the copper coil. So once again I am telling here, take a cylindrical material which is made up of a plastic or it is made up of a paper like material, and wound number of copper rounds here with the copper wire, and you have to connect the both end of the copper wire to the ammeter. Now you have to take a bar magnet. Imagine that this is a bar magnet, and continuously we have to move this bar magnet inside this coil, inside this coil and outside this. You have to move that bar magnet inside and outside continuously and simultaneously observe the change in the ammeter. Isn't it? Before you are doing that activity, the ammeter will be rest at it shows the direction at the 0. But when you are going to move the magnet inside this coil, it shows somewhat deflections here. So that shows somewhat current will be produced. I am making one model here, you have to see here. So this is a cylindrical coil. The copper coil will be wounded continuously with a number of turns, and one end of the copper coil, will be attached to the one end of the light bulb here, and under one end of the copper coil will be attached to the under one end of the bulb. So this is the magnet. I am showing one activity. We have to clearly see here. By moving the magnet continuously inside this coil, the magnetic field applies some force, electromagnetic force on that coil, and that produces the current. That electric current, it is nothing but the induced electric current, and that complete phenomena is known as the electromagnetic induction. You have to see clearly here. The light will be glows. You have to clearly observe. When I am moving continuously the magnet inside the coil, isn't it? You have clearly seen here the light will be glows with the help of when the magnet will continuously moves here. If I am stops the movement of the magnet, if I put the magnet inside that coil, there is no current will be flowed. But by the motion, the change in the magnetic field, isn't it? So it produces some electric current, and this current is known as the induced current, and this phenomenon is first time observed by the Michael Faraday, and this is explained by the Fleming's right hand rule. How it works, that is nothing but the electric generator. Using this activity, we are going to make this use of this activity to convert the motion of the mechanical work into electrical work, the electric current. So this is the mechanical work, isn't it? This is the mechanical work. The mechanical work, it will be converted into electric current, that is a light glows, isn't it? That will be studied with the help of the Fleming's right hand rule. So this current, it is induced, the current induced here, the current comes here, that is called it as an induced current, isn't it? And the total phenomenon is known as the electromagnetic induction. And what is electromagnetic induction? When a conductor is placed in changing magnetic field, when a conductor is placed in a changing magnetic field, so this is the magnet, it has the magnetic field. When conductor is placed in a changing magnetic field, the magnetic field will be changes here continuously with the movement of the magnet, isn't it? When conductor placed in a change in magnetic field, some current will be induced. Here the light will be glow due to some induced current due to the motion of the magnet, change in the magnetic field. When this magnet moves continuously, the magnetic field act on this coil also changes. So change in the magnetic field induces some current, and this current, it is called it as an induced current, and this total phenomenon, it is called it as an electromagnetic induction. When a conductor is placed in a changing magnetic field, some current is induced, and such current, it is called it as the induced current, and the phenomenon, it is called it as electromagnetic induction. Using the electromagnetic induction, we prepare a device that is called it as an electric generator. If you are going to see the old bicycles, one device will be present at the back wheel of the cycle, that is one device will be present. Using that device, the front light will be glowing. That device, it is nothing but an electric generator. How the electric generator will be constructed and how it is works, that will be studied with the help of the Fleming's right hand rule. So the electric motor will be works on the principle of the Fleming's left hand rule, and the electric generator works on the principle of the Fleming's right hand rule. What is Fleming's right hand rule? What it says, see here. So again you have to consider the three fingers of the right hand here, the thumb finger, forefinger and middle finger. You have to consider three fingers in a such a way that they are mutually perpendicular to each other. You have to consider the three fingers in a such a way that this finger will be perpendicular to thumb and this finger will be perpendicular to the middle finger. So in such a way that all the three fingers are mutually perpendicular, and the thumb finger indicates, so the thumb finger indicates here motion of the conductor. So in the example, the conductor will be stationary and the magnetic field will be changes, but in the electric generator the magnetic field will be constant, the conductor will be continuously changes here. So the opposite to the experiment what we did here. So what happens in the electric generator, they are going to keep the magnetic field fixed here. The magnetic field is stationary here, but the conductor is continuously moves. So that will be explained with the help of the Fleming's right hand rule. So forefinger indicates the direction of the magnetic field. This forefinger indicates the direction of the magnetic field. If the direction of the magnetic field in this direction, the forefinger indicates the direction of the magnetic field, and the thumb indicates the direction of the motion of the conductor. The thumb indicates the direction of the motion of the conductor, and the forefinger indicates the direction of the induced current. Is it clear? So the electric generator, it is based on the principle of the Fleming's right hand rule. According to the Fleming's right hand rule, the forefinger indicates the direction of the magnetic field, and the thumb indicates the direction of the motion of a conductor, and the middle finger indicates the direction of the induced current. With the help of this, the electric generator will be worked. So now we are going to see how the electric generator will be constructed. In your examination, one question should be asked on this for 3 to 4 or 5 marks question. Write the construction and working of electric generator with its principle, isn't it? Now we are going to see how the electric generator will be constructed. The electric generator consists of 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 a rectangular coil ABCD, a rectangular coil ABCD placed in between two stationary magnets. And see here, this is ABCD, it is a rectangular coil placed in between two stationary magnets, and the two ends of the coil are attached to the two rings two rings R1 and R2 separately. R1 and R2 separately. We have to see here the two ends of the coil. This is one end of the coil, it is attached to the one ring R1, and another one end of the coil that is attached to the another one ring R2. And R1 and R2, the rings R1 and R2 are the rings R1 and R2 are attached to the axle in a such a way that the coil will be rotated mechanically with the help of axle. So the inside these rings R1 and R2 are insulated and attached to the axle. This is the axle. These two rings are attached to the axle in a such a way that this copper coil will be rotated very easily with the help of the axle by external force. We can easily rotate this coil with the help of this axle. And see, the ring R1 and R2 has the brushes B1 and B2. Rings R1 and R2 has brushes B1 and B2 and that are connected to a ammeter. See here, the ring R1 and R2 has the brushes B1 and B2. These B1 and B2 are connected to a ammeter to check the induced current here. So how it works? This is all about construction of the electric generator. Electric generator consists of a rectangular coil ABCD. The two ends of the rectangular coil are attached to the two full rings here, not a half rings, two full rings R1 and R2. These are these two rings are attached to the two stationary brushes B1 and B2, and the ends of these brushes are connected to the ammeter, and this electric coil, the coil will be placed in between the two stationary magnets. How it's work, how the works continues here, how it works here. See here, when the axle rotates in ABCD direction, when you are going to rotate AB, the AB will move down and CD will comes up, and CD will comes down and AB will moves up, isn't it? The continuous motion of the coil with the help of the axle, when we are going to physically rotate this coil with the help of the axle, AB moves downwards and CD moves upwards, and again CD moves downwards and AB moves upwards. What happened here? The magnetic field will be constant here. The magnetic field will be constant, and conductor is continuously changing its position. So due to the change in the due to the change in the conductor, due to the magnetic field, somewhat current will be induced here, and that current will be flows through the two ends of this coil, and then we get the deflection in the ammeter. isn't it? So the magnetic field which produces here, that will be constant from this magnet and this magnet, but due to the change in the direction of the conductor, due to the motion of the conductor, the magnetic field induces some current inside this coil, and that current will flows through the two ends of the coil, and that will be shows the deflection in the ammeter, that is nothing but the induced current. So in the rotation, what happens here, when AB moves down, the brushes are constant here, the brushes doesn't changes its axle, that brushes are also always contacted with the rings. The brush B1 always connected with the ring R1, and the brush B2 is always connected with the ring R2. Therefore, when the axle continuously rotates, the current will be flows, and that induced current will show some deflection in the ammeter. So, and the current which we get here, it is induced current. With the help of this electric generator, number of activities are going to be done in today's life. That is, this electric generator will be used in vehicles also. This electric generator will be used in the when in the production of electricity in the some of the areas. To get electricity, to produce the electricity, we use this phenomenon. This is all about the electric generator. So from the electric generator or from electricity we get, there are two types of the electricity we get, that is electric current we get, that is DC current and AC current. AC current, it is the alternating current. That is what is meant by the alternating current here. The amount, that is the electric current, it doesn't has a fixed amount here, isn't it? The value of the current, it is not fixed, it is always changing, that is alternating current. But DC current, it always flows in a definite amount, that is it is called it as a direct current. All the batteries which produce all the batteries which we are going to get, that is a DC current, and the current which we get from the electric poles, that is AC current, that is alternating current. So students, the last topic of this lesson, that is nothing but the domestic electric circuit. How the domestic electric circuits are going to be connected. We are going to get the electricity from the electric poles, but when we are going to see the electric poles, we are going to see three wires here. In which wire we are going to get the current, with which wire we are going to get the current to our home, that will be studied by the domestic electric circuit. See, there are three kinds of wires are used. There are three kinds of wire will be used in the electric poles. So commonly, when you are going to get the electricity from the poles, you are going to see three wires. But in case of some of the electric poles have 5 to 6 wires. But in that case, that 5 to 6 wires, that will not supply a domestic current to the homes, but it supply the current to some of the industries. We have to remember that connection will be provides the current to the industries that have, in that cases, 3 lives are present, that is it is called it as a 3-phase, that will be studied next. But commonly, when we are going to see a electric pole which provides the electricity to the domestic houses, it has 3 kinds of wires. One, it is a live wire with the positive, that is, the live wire indicates with the positive wire with a red insulation cover. So when you are going to see the wires which are present in your home, or you have to see the wires which are attached to the wires which are present in the poles, the red wire indicates it is a live wire, that is it is a positive wire. And second wire, that is second type of wire, it is a neutral wire, that is a negative wire indicated with a black insulation cover. And another one wire it is present here, that is a earth wire, that will be indicated by the green insulation cover. So we are going to see 3 types of the wire in the poles, which in the domestic electric circuits. We get the electricity from the poles towards our houses. How the electric current will be passes here? From the pole, the current will be enters into the main supply. The main supply socket will be present in our home. The main switch is present in our home. If we are going to off the switch, the electricity passes through it stops the flow of the electricity towards all parts of our home. That switch. So first the electricity enters from the pole to the main supply, and then it enters into the fuse. Why the electricity enters the main supply to the fuse, or why the fuse is introduced here? Because in case of we are getting the current here, alternating current, the value of the current will be changes here. At the case of overloading, this fuse will be helps here. What happens in the overloading action? So what happens here? The fuse consists of a thin wire here that has the low melting point. When the current, high voltage current or overloading happens, the thin wire will be melted due to the high voltage of current, and that will be prevents our machinery particles or our electrical particles which are present in our home. If the fuse is not present here, the overload supply will be continuously flows throughout our home, and our electrical appliances will be demolished here. So that's why they are going to be wasted. So to prevent this action, we are going to use here the fuse that will be works on the principle of electric heating effect, isn't it? Then by the fuse, the electric current will move towards an electric meter. You have to see in your home, one meter will be present at outside of your home. With the help of that meter, the power mans are going to be give you a bill that will be the electric current will be flow towards that electric meter to count the amount of the electricity which you are going to use for a month or for a year. Then from the electric motor, the electric current flows towards the distribution box. So it is not directly flow towards all the sockets or all the rooms which are present in our home, but first from the electric motor, that current will be flows towards the distribution box. From the distribution box, it go towards to the another to separate sockets or the two separate rooms. The electricity flows. So that all will be indicated by the simple diagram here. This is the three types of the wires which they come from the electric pole. That is earth wire, live wire, and a neutral wire. The earth wire will be green in color. That is, the earth wire will be covered with a green insulation cover, and the live wire, it is red in color. That is, the live wire will be insulated by the red insulation cover, and a neutral wire that will be covered with a black insulation cover. See here, sometimes this color, the black insulation color, will be changed, or it can be used as a blue color also. So don't get confusion here. In the place of the black, we can use blue color also, but the live wire, it is always red in color, and the neutral wire, it is always in blue in color, and earth wire, it is in green in color. So why we need this earthing wire here? Why we need the earthing wire? Because at the situations, sometimes these earthing connections will always connected to the all main important electric equipments which are present in our home. For example, if you are using a computer, you have to remember an earthing should be attached to the electric computer here. Why? Because at the time of the overloading, through the earthing, the overloaded electric current will be flows towards the earth, and our computer will be safe from the overloading here. And also another one most important use of the earthing wire here. So if you are going to see the new buildings, the one iron rod will be placed at the top of the building. Why? Because to get the prevention from the lightning effect. The lightning effect has an electric current. If you are not placing that earthing rod at the top of your building, the lightning will causes lot of the effect on your earth, and such in such a way we are going to protect, if we are going to protect our electrical devices from the earth lightning, we should place the earthing to our we should attach the earthing wire to our all electrical equipments. This is all about the domestic electric circuit, and in the PD between the potential difference between the neutral wire and the positive wire and the negative wire is in the India it is about 220 volt. So be careful that the electrical pole wires has a high amount of the electricity, the voltage of the electricity is very high. So when you are going to work with that wires, it is you have to take very carefully precautions in that condition. So this is all about how the domestic electric current circuit will be present in our home. So this completes your another one most important chapter, magnetic effect